Hello students, let us begin the revision on surface area and volume. First, we shall take up the main concepts and the results involved in this chapter, followed by solving questions from NCERT exemplar. The main concepts and the results of this chapter are: the surface area of an object found by combining any two basic solids, namely cuboid, cone, cylinder, hemisphere, sphere. The volume of an object formed by combining any two of basic solids, namely cuboid, cone, cylinder, sphere and hemisphere. The formula involving the frustum of a cone or volume of frustum of the cone is 1 by 3 pi h times of r1 square plus r2 square plus r1 r2. The curved surface area of the frustum of a cone is pi times r1 plus r2 multiplied to the slant height. The total surface area of the frustum of the solid cone is pi L times R1 plus R2 plus pi R1 square plus pi R2 square, where L is h square plus R1 minus R2 whole square, where h is the vertical height of the frustum, L is slant height of the frustum, and R1 and R2 are the two bases at the end of the frustum. A solid hemisphere will be having the curved surface area as 2 pi r square and total surface area will be 3 pi r square, and the volume is 2 by 3 times of pi r cube. Volume of a spherical shell is 4 by 3 pi times of r1 cube minus r2 cube, where r1 and r2 respectively are the external and the internal radii. Throughout this chapter, we take up pi is equal to 22 by 7 if not stated otherwise. These are the basic main concepts. We shall take up exercise questions and we shall revise each of the topics. We'll begin with exercise 12.1. Exercise 12.1 is all about choosing the correct answer in the given 4 options, of which the first question is: a cylindrical pencil sharpened at one edge is the combination of. First option is cone and a cylinder. Second option is frustum of a cone and a cylinder. Third option is a hemisphere and a cylinder. And the fourth option is 2 cylinders. A sharpened pencil would look like this. It's a combination of a cylinder added to a conical shape. The nib of the sharpened pencil is a conical shape. The rest part of the sharpened pencil is a cylinder. Therefore, a pencil is a combination of cylinder and a cone. So, the right option is option A cone and a cylinder. Second question: a Surah is the combination of. Option A is a sphere and a cylinder. Option B is hemisphere and a cylinder. Option C is 2 hemispheres. Option D is a cylinder and a cone. Let me show you how a Surah look like. It's a combination of a sphere and a cylinder. This conical flask is called as a Surah, and it's a combination of a sphere on the top there is a cylindrical part. The top of the surah is a cylindrical part and the bottom of the surah is spherical sphere. Therefore, surah is a combination of sphere and a cylinder, and the right option is a sphere and a cylinder, option A. Question 3. A plumb line, Sahul, is the combination of, you can look at the figure 12.2. This is figure 12.2. It's a combination of, if you look at the bottom portion, it is a conical portion and the top portion is a hemispherical portion. The upper part of the plumb line is a hemispherical, bottom part of the plumb line is conical, therefore the combination of hemisphere and a cone. So the right option is option B, a hemisphere and a cone. Question 4. The shape of a glass tumbler, you can look at question 12.3, is usually in the form of, this shape we have learnt, it is the shape of frustum of a cone. In turn it is inverted frustum. So the right option is option B, frustum of a cone. Question 5. The shape of a gilly in the gilli danda game, which is seen in figure 12.4, is a combination of, you can look at this particular figure, it's been split here. There are two cones and a cylinder. The left and right part of the gilli is a conical shape. The central part of the gilli is a cylindrical shape. Therefore, it's a combination of a cone and cylinder. So the right option is option C, two cones and a cylinder. Question number 6. A shuttlecock used for playing badminton has the shape of the combination of, option A is a cylinder and a sphere. Option B is a cylinder and a hemisphere. Option C is a sphere and a cone. Option D is a frustum of a cone and a hemisphere. A shuttlecock would look like this, and on the top we have got a hemispherical shape, and the bottom we have got the shape of frustum of a cone. So the right option is frustum of a cone and a hemisphere. Option D is the right answer. Question number 7. A cone is cut through a plane parallel to its base, and then the cone that is formed on one side of that plane is removed. The new part that is left over on the other side of the plane is called, option A is the frustum of a cone, option B is cone, option C is a cylinder, option D is a sphere. For the better understanding, I have taken a cone. When a plane is making a slice of a cone, the conical part, if it is removed, we will be getting frustum of a cone. When a cone is divided into two parts by a plane through any point on its axis parallel to its base, the upper part will be a cone and the lower part will be a frustum. These are the two parts. The upper part is cone itself and the lower part is a frustum of a cone. So the right answer is frustum of a cone. Question number 8. A hollow cube of internal edge 22 cm is filled with spherical marbles of diameter 0.5 cm and it is measured. Assume that 1/8 of the space of the cube remains unfilled. Then the number of marbles that the cube can accommodate is. So this question has to be solved. Here, as per the question, the edge of the cube is 22 centimeter, so that I can find out volume of cube. So the volume of cube is 22 whole cube. When we cube this 22, we'll be getting 10648 centimeter cube. This is the volume of hollow cube. Volume of cube that remains unfilled is 1/8. So I'll write that volume of cube that remains unfilled is 1/8 of 10648 centimeter cube, and this will be 1331 centimeter cube. Now I'll find out the volume of cube that occupied by spherical marbles. Is 10648 minus 1331. This is 9317 centimeter cube. We are given the diameter of the spherical marble, so I can find the radius. This will be half of the diameter, 0.5 by 2, which is 0.25 centimeter. For calculation purpose, I'll write this as 1/4 centimeter. Now, volume of one marble will be 4 by 3 pi r cube. 4 by 3 into pi value is 22 by 7 into r cube is 1 by 4 whole cube. Here there is no more space, so directly I will write the answer. You can verify this, 11 by 168 centimeter cube. Now we need to find the number of marbles. This will be the volume left out which can be filled with the marbles, 9317 divided by 11 upon 168. On calculation, we get 142296. So 1,42,296 marbles can be filled, and it is present in option A. In surface area volume, you will be having questions like this. It would take more time to solve, but then you need to remember all the formulae and substitute and calculate. Let's look at the next one. Question 9. A metallic spherical shell of internal and external diameters are 4 cm and 8 cm respectively is melted and recast in the form of a cone of base diameter 8 cm. The height of the cone is. When I take the cross section of the spherical shell, it would look like this. One of the diameter is 8 cm and another diameter is 4 centimeter. The internal diameter is 4 centimeter. So for this shell, I will consider R1 to be the internal radius, which is half of 4 centimeter. It becomes 2 centimeter. I'll take R2 as a external diameter, R2 as the radius of the external circular part. So external radius will be half of 8 centimeter, which is 4 centimeter. Whenever we are having spherical shell, volume of spherical shell is given by the formula 4 by 3 pi times R2 cube minus R1 cube, where R2 is the external radius and R1 is the internal radius. Let us substitute the value. It becomes 4 by 3. I'll retain this pi. At the end I'll substitute the value. R1 cube is 4 cube minus R2 cube is 2 cube. 64 minus 8 is 56. So 56 multiplied to 4 is 224. We get 224 by 3 times pi centimeter cube. And this particular volume of sphere is being recast in the form of a cone. And they have given the base diameter as 8 centimeter. So radius of cone will be, this is for a spherical shell. This one is for cone. Here I should write spherical shell instead of sphere. You can make a suitable correction there. So the radius here will be 4 centimeter. If I consider h as the height of cone, which is to be found, volume of the cone is given by 1 by 3 pi r cube, pi r square h. This volume should be equated with the volume of a spherical shell, because the same thing is being recasted. Therefore 224 upon 3 pi will be equal to 1 by 3 pi into r square is 4 square multiplied to h. Here let me change the ink. Pi will get cancelled, 3 will get cancelled, and h will be equal to 224 divided by 16. This becomes 14 centimeter. Therefore, height of cone is 14 centimeter, which is there in option B. So option B is the right answer. With this question, I'll end today's session. We shall take up some more questions in the next session. Thank you.